Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello, everybody, to today's episode of Pepperl+Fuchs Plugged In. And with me today again is Eduardo Bustillo. Hello, Eduardo.
Hi, Helga. I'm happy to be on again.
Great. Eduardo, you have a sensor with you today for us, and it's not your standard inductive sensor. This is something special. Tell us about it, please.
Yeah, this is a brand new technology from Pepperl+Fuchs. It's a brand new family of sensors, and it's something that we're really excited about. It's a little bit more advanced than your typical on-off sensor, but it's something we're really excited about here at PNF.
So, what is it? Tell me.
So today we're going to be talking about our measurement inductive sensors. These are going to come in a few different flavors, but basically you are able to physically measure the distance from the sensor to a target, and you can get a proportional output depending on that distance. So slightly more advanced than a regular proc switch.
So in a sense, it's an analog sensor. Those have been around for a long time, but this is still a step above that. It's not just your run-of-the-mill analog sensor, is it?
You're right. It's much more than just a run-of-the-mill sensor. It not only measures distance, but we also have versions that can measure and relay the acceleration and speed and direction of whatever it is looking at.
So that is now opening up several new applications. But before we get to the applications, tell us a bit about the form factor, because, after all, our customers need to mount this product. What do they look like?
So the beauty of this is that they look exactly like our regular inductive sensors that we're all familiar with. We have these in the 4 standard cylindrical sizes and 2 rectangular sizes. So these are commonly used in industry, and it's housings that we're all familiar with, basically, for our standard inductive proxies.
And those are?
We have an 8 millimeter, 12, 18, and 30 millimeter cylindrical sensors, and also our Rhino style housing and a smaller surface mount style housing.
And I'm assuming that the cylindrical versions come as almost always flush and non-flush versions.
That's correct. Yep. We have options in all the cylindrical sizes and the rectangular housings in both non-flush and flush.
Okay, very good. So mounting really is easy. Usually, Eduardo, we don't like to talk about numbers much, but this time I have to ask you, what is the range that these sensors can detect the metal target at? What's the maximum range we can offer?
So of course, like any inductive sensor, the range will depend on the size, but on the larger end, the largest sensor with the largest non-flush sensor will have a range of 30 millimeters, and that's the Rhino.
Okay. And give us an idea of the speed. Are we talking slow speed, high speed? What can our customers measure with these sensors reliably?
So on our speed measurement versions, the maximum speed is going to be 3 meters per second. That's a pretty fast. That's a pretty fast bike ride, a pretty fast sprint. It's not slow by any means.
Okay. Wow. I'm very interested in hearing now what that allows us to do. So give us a sense of applications.
So essentially, it's a short range measurement device, a short range positioning device. So the applications that we can cover with this, I mean, it really opens up so many things for us. First, these were mainly intended to be used for shock absorbers in different types of pick and place machines, for example. That's really where these really shine, because you're looking at a high speed target moving back and forth over a relatively short distance. So you're really, really focused on this small but very, very quick movement. So that's what they're designed for. But the applications don't stop there. There's many more applications that we can cover with this new type of technology we have.
Okay. So those are, for instance?
One good example is the monitoring of a rotating cam, whether that's on a pick and place machine or any other type of machine. These sensors, one good application, you can mount them facing the side of a rotating cam, and as the rotating cam moves, the sensor will tell you how far it is to the edge of the cam, and then from there, depending on the shape of the cam, the profile of the cam. You can get a lot of information about whatever the cam is connected to. You can get information about how much is rotated and things like that. So that's another good application for us.
Okay. Do we have applications that are in material handling? After all, material handling is a very hot topic these days, and warehousing and reliability of warehousing is a topic. So anything in that space?
Yeah, we have one really interesting one right now where this sensor is being used to monitor the sag on a drive chain of a monorail. Since these sensors are constantly looking and measuring the distance to the target, once the chain, for example, once it starts to sag too much or not enough, perhaps, then the sensor will know, hey, this chain is too far out of spec. It needs some maintenance. It needs someone to look at it. But yeah, that's another good application for us, monitoring the sag or the tension on a belt.
So it sounds to me a bit like this sensor is a combination of a detection device that offers quite a bit of condition monitoring features.
That's correct. Yeah, the speed and acceleration versions of our measurement sensors, they really are also condition monitoring devices. The user can set a certain threshold that is too high for a certain value of speed or acceleration or distance. And then from there, you can tell when something is either out of spec or whether it needs replaced. And the user can define what exactly those specs are. Going back to the chain example, if you know that once your drive chain starts to sag more than a few millimeters, if you know that that is too low of a tension, the sensor is smart enough to know that once you set that distance, it'll let you know, hey, this chain is out of spec. Someone needs to look at it.
Okay. All right. Good. Well, Eduardo, I think we need to start wrapping up. So as always, I'd like you to think about a 5-word statement. And while you think about it, I'll try to summarize what we discussed, and then looking forward to understanding or to hearing what you find or what you think the 5 words should be that our audience should take away. So we were discussing today our new line of inductive measurement sensors. These are available with analog outputs, and they provide distance to a target. But more than that, in their IO link versions, these sensors can also measure the speed and the acceleration of a target with regards to the face of the sensor. The range is fairly typical for an inductive sensor in the 30 millimeter max range, but the speed that an object can move by or move towards the sensing face can be a very brisk, up to 3 meters per second. So that is way past walking speed. Now you need to hop on a bike to get there. So it's pretty fast. Applications range from shock absorber to cam rotation measurement, and even include speed of monorails, chain sag, and these types of applications where distance is a value that somehow relates to the quality and the status of the line. And so that makes these inductive sensors a mixture of detection and condition monitoring sensor. I think that's about it. That's what I got. Did I miss anything critical, Eduardo?
I don't think so. I think that's a pretty good summary. And yeah, these are very unique devices. And yeah, you can get a lot of valuable information from the IO Link versions, especially.
All right. So what's your 5-word statement of the day, please?
One sensor, completely captured motion.
Okay. Yeah, I like it. Captured motion. That's the good one. That relates back to the shock absorber. That relates back to the chain sag. That relates back to the rotating cam and so forth. Excellent. One sensor, completely captured motion.
Especially on the speed and measurement, the speed and acceleration versions, you get not only position measurement, but also velocity, which is speed and direction, and it calculates an acceleration also. You get the entire motion captured, speed, direction, everything.
Great. Eduardo, I appreciate it. Thank you very much. And thank you very much out there for listening to our Pepperl+Fuchs Plugged In podcast today. Have a great day. Bye-bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.